Russia and Iran satellite launch, strategic ties, and space tech. A satellite launch that's more than just science, and a power politics in orbit. In a move likely to provoke intense scrutiny from global powers, Russia has successfully placed a new Iranian communication satellite into orbit using one of its reliable Soyuz launch vehicles. The timing and symbolism of this action suggest more than mere technological progress. It's a strategic handshake between two nations increasingly aligned against Western influence. The rocket was deployed from Russia's Vostochny Cosmodrome, situated in the country's remote eastern regions. Alongside Iran's Nahid-2 communication satellite, the payload included 2 Russian Ionosphere-M satellites for Earth study and 17 additional mini-Russian satellites. Newsweek is currently seeking official responses from both Iran's and Russia's foreign ministries. The bigger picture. This latest collaboration marks another chapter in Iran and Russia's growing tech alliance, a trend unsettling to Washington and European allies. Their coordinated efforts in aerospace innovation raise red flags in Western capitals, especially given fears that Iran's civilian space advancements might bolster its ballistic missile capabilities. It's an enduring concern, rooted in the dual-use nature of space launch technologies. The same rockets that carry satellites could, in theory, be modified to deliver weapons. And here's the part most people miss. The satellite blastoff occurred mere hours before key nuclear talks between Iranian and European representatives. Was this just coincidence or a calculated flex? Meet Nahid-2. Iran's Nahid-2 satellite represents another step forward in its homegrown space program. As described by Iranian state media, it's a fully domestically designed and produced device meant for communications. The satellite weighs around 110 kilograms, roughly 242 pounds, travels in a low Earth orbit of approximately 500 kilometers, 310 miles, and is expected to operate for 2 years. Western response: cautious, skeptical, concerned. Predictably, Western governments continue to sound alarms about Iran's space ambitions. Their argument? These technologies aren't just about internet access or TV signals. They could eventually support military goals. Just earlier this week, Iran launched its own Coincided satellite rocket to test new technology. Officials characterize the test as an effort to experiment and refine future satellite functionality. However, many see it as another indication of dual-use strategy. A new diplomatic round begins. On the very day of the satellite launch, nuclear negotiations resumed in Istanbul. The talks feature Iran and the E3 alliance, France, Germany, and the UK. This marks the first formal dialogue since a military exchange in June, when Israeli strikes on Iranian installations escalated tensions across the region. The U.S. sided with Israel in that clash, targeting Iranian nuclear assets. Coincidence again? Or are these strategic actions in orbit and on Earth more tightly coordinated than meets the eye? What experts are saying. Sina Azodi from the Elliott School of International Affairs summed it up. Iran isn't just building satellites. It's delivering messages. The Nahid-2 launch, then, might be both literal and symbolic. Looking ahead, with renewed diplomatic engagement and ongoing space launches, Iran's moves, especially those involving Russian cooperation, will likely draw increasing scrutiny. How far will these partnerships go? What boundaries will the West try to enforce? And who really benefits from the tension? Let's talk. Do you see Iran's satellite program as a peaceful pursuit of tech advancement or a veiled step toward military capability? Should Russia face consequences for enabling these launches? Let's hear your thoughts in the comments below. Is this cooperation brilliant strategy or reckless provocation? Russian rocket launches Iran's Nahid-2 communication satellite into orbit. Imagine the geopolitical shockwaves that ripple through the international community when a Russian rocket successfully launches an Iranian satellite into space. This isn't just a technological feat, it's a bold statement that has Western governments on edge. According to Iranian state media, the Nahid-2 communications satellite was launched from Russia's Vostochny Cosmodrome using a Soyuz rocket. This event marks a significant milestone for Iran's aerospace program, which has long been a source of concern for Western nations. But here's where it gets controversial. The satellite, weighing 110 kilograms, 240 pounds, was designed and manufactured entirely by Iranian engineers. This raises the question: how far can Iran's technological advancements go And what implications do they have for global security? Western governments have long expressed concern that the technological advances made in Iran's space program could also be used to upgrade its ballistic missile arsenal. This is the part most people miss. The launch of the Nahi-2 satellite comes at a critical time, just as nuclear talks between Iran and Britain, France, and Germany are set to begin in Istanbul. These talks, which started on Friday morning, are the first since Israel's mid-June attacks on Iran, which led to a 12-day conflict and the intervention of the United States, which attacked Iranian nuclear sites. The timing of this launch is not lost on international observers, who are closely watching how these developments might influence the delicate negotiations. In December, Iran made headlines by announcing it had put its heaviest payload to date into space, using a domestically manufactured satellite carrier. This was a clear demonstration of Iran's growing capabilities in space technology. And in September, Iran successfully put the Chamran-1 research satellite into orbit using the Hayim-100 carrier, which is produced by the Islamic Revolutionary Guard Corps Aerospace Division. This raises an intriguing question. How will the international community respond to Iran's continued advancements in space technology? Will these developments lead to further tensions, or could they open the door to new diplomatic opportunities? We'd love to hear your thoughts in the comments. Do you believe Iran's space program is a cause for concern, or is it a testament to the country's technological prowess? Let's discuss. Russia launches Ionosfera-M satellites to study Earth's ionosphere and space weather. Imagine a pivotal moment in space exploration where a Soyuz 2.1B rocket soared into the sky, marking a significant step in Russia's quest to understand our planet's ionosphere. But here's where it gets controversial. This launch wasn't just about one mission. It was a multifaceted endeavor that included not only the Ionosfera-M satellites, but also a mix of secondary payloads from both Russian and international sources. On Friday, July 25th, at 5:54 UTC, the Soyuz rocket lifted off from Site 1S at Vostochny Cosmodrome, tracing a northern path over vast, largely uninhabited regions of Russia. The primary cargo for this mission was the Ionosfera-M number 3 and number 4 satellites, which were destined for a sun-synchronous orbit at an altitude of approximately 800 kilometers. These satellites, along with their predecessors, Ionosfera-M number 1 and number 2, launched in November 2024, will form a 4-satellite constellation aimed at studying Earth's geophysical environment, space weather, and its impacts on our planet. This ambitious project, known as Project Ionizon, underscores Russia's commitment to advancing scientific research despite financial challenges. But the story doesn't end there. The Soyuz 2.1B rocket also carried 18 secondary payloads, including 17 Russian satellites and one from the Iranian Space Agency. Among these were a 16U CubeSat and 16 3U CubeSats representing different Russian commercial organizations, alongside Iran's Nahi-2 telecommunications satellite. This diverse payload demonstrates the versatility and collaborative spirit of space missions today. Vostochny Cosmodrome, the launch site for this mission, plays a crucial role in Russia's space strategy. Developed as a domestic alternative to the Liev Baikonur Cosmodrome in Kazakhstan, Vostochny aims to reduce Russia's dependence on foreign launch sites. The cost of leasing Baikonur until 2050 is a hefty $115 million annually, making the development of Vostochny a strategic move. The Ionosphere-M satellites, each weighing around 400 kilograms, are designed to operate for 8 years. They are equipped with a suite of 9 scientific instruments, including 4 spectrometers, a shortwave sounder, a magnetometer, an energetic particle sensor, and a radio wave sounder. These instruments will provide detailed measurements of the ionosphere, offering insights into its plasma, particles, and radiation. One interesting aspect of the Ionizon project is the Zond-M satellite, which was intended to observe the sun from a sun-synchronous orbit. However, due to budget constraints resulting from the Russian invasion of Ukraine, the Zond-M mission was suspended in late 2024. This highlights the ongoing financial pressures faced by space agencies worldwide. The data collected by the Ionosfera-M satellites will be invaluable for various applications, including space weather forecasting by Rohidromet and research by the All-Russian Scientific Research Institute of Electromechanics, JSEBNIEM. Understanding the ionosphere is crucial for navigation systems, communication technologies, and even predicting solar storms that can affect power grids and satellite operations. To give you a better picture, Earth's atmosphere is divided into several layers, each with unique characteristics. The troposphere, stratosphere, mesosphere, thermosphere, and exosphere all play vital roles in protecting and supporting life on Earth. The ionosphere, located between 80 kilometers and 650 kilometers above the surface, is particularly fascinating because it influences radio communications and creates stunning auroras during solar storms. In conclusion, this launch represents a significant milestone in Russia's space endeavors, showcasing its technological capabilities and scientific ambitions. As we continue to explore and understand our cosmic neighborhood, such missions are essential for advancing our knowledge and ensuring the resilience of our technological infrastructure. What do you think? Should more focus be placed on studying space weather and its impacts on Earth? Share your thoughts in the comments.